So welcome to my talk, Why Your Best Engineers Should Look After the Worst Systems, which is probably not a great title, but basically I like legacy. And I'm hoping that at the end of it, you won't hate it too. So I'm going to try and challenge legacy code because a lot of the time people are treating it like a swear word. So first about me. So this is a very bad picture of the avatar that I use everywhere. To put it into context, my age is that I remember Java 1.1 and actually used it commercially. And how exciting was it when Java 1.1 came out and you had like anonymous classes that were like lambdas. And don't worry, this is about as technical as it gets. There won't be any more references to legacy code. No, actually there will be. Right, so I'm interested in old technology. And if you look at the list of clients that I've had, they were probably interested in old technology as well. Now, nowadays, I actually work in application security. So effectively, I live in a special kind of hell trying to secure legacy code. So very briefly, in this talk, I'm going to try and define what legacy code actually is. I'm going to put it into context. And yesterday, Jeff told us that we have to start with a business problem. And oh boy, legacy is often a problem for the business, isn't it? I also want to look at sort of what I call the maintenance death spiral. Also about language. Some of the language that we use with legacy code influences how we think about it. And then trying to sort of work out what we can do about it. The fact that experience actually matters, that we do want small teams and autonomy to deal with legacy code. And at the end of it, I'm going to see what legacy can do for you. So to start off with, what is legacy code? So that's what we're going to do first. Is it just old systems? Is it just mainframes? Is it just COBOL? Well, if we look at what Michael Feathers said in his book, legacy code, the main thing that distinguishes legacy code from non-legacy code is tests, or rather the lack of them. Let that sink in for a moment. The problem is that you can't test it. Now, how many people work in environments where you write new codes that you can't test? The problem is that today's new code is going to be tomorrow's legacy code very quickly. Now, in about my 25 years as a developer, I've often found code that you can't test, where you've got an old piece of code that is in a repository, not even GitHub. Maybe it's not even in a repository. Maybe you get it as a zip file somewhere and somebody hands it to you and say, right, you now, I see some chuckling over there. That must sound familiar. So what does this mean? No automated tests makes making changes more difficult. And Phil was talking about this just before, that, we want to introduce continuous delivery in order to make making changes easy. Because if we can't make changes easily, we can't fix bugs, we can't make security fixes, we can't change little glitches that happen in the user interface. What about enhancements? It's all based on tests. So throughout this talk, I'm going to use an example, and this is an engagement that I worked on, which is basically taken some old legacy code out of a data center and move it into the cloud. The aim wasn't to fix bugs. The aim wasn't to improve things. It was basically take this box out of the data center, shift it over into the cloud, because running in the cloud is exciting. Yeah, it was a simple problem. And it won't surprise you that this was a government department. And yes, the source code was in a zip file. And there were 70 monolithic services. So lots and lots and lots of code. So let's remind ourselves what Michael Feathers was saying. Code without tests is legacy code. And those 70 monolithic microservices delivered as a zip file, they had no tests. Well, they did, but the test coverage was around the single digits, and they were written in such a way that they tested everything to the letter, so that if you changed a line of code over here, all your tests broke regardless of what you changed. So I'd like to qualify it a bit. Code without tests that you can trust is legacy code. So you might even have some tests, but if the quality of the tests is that you just run it and it breaks and it doesn't really tell you anything, then it doesn't matter whether you have tests. You know, a folder with the name tests and lots of files in it is not enough. Often you also have the problem that when it comes to lift and shift, that things go from one supplier to the next. And sometimes I think of it as rather than lift and shift, as more like lift and shit. And you don't end up sort of fixing bugs. You just go and say, right, let's just do what we got paid for. So we didn't actually know when we were doing, back to my example, we didn't know whether we were doing the right thing because we didn't have any tests that we could trust. And I'm going to qualify this even further, saying code without tests that anyone can trust is legacy code. So if you have got some tests that only you can run, and then you hand that off to somebody else who doesn't understand how the tests work, then that is also still legacy code. So another way of saying this is that if you create a knowledge silo where you hoard all the knowledge of the system to yourself, then that creates legacy code, even if you have the best practices. And considering this is an Agile conferences, I think Agile ways such as pairing and continuous integration is really useful to prevent falling into that silo trap. Right, classic cars. I've cunningly put lots of classic cars in the last few slides. Now, I'm not a car enthusiast, but even I know that some of the classic cars that you get now are even more valuable than they were when they first came out. So what about classic services? Now, interestingly, that was the name that we gave ourselves when we were lifting and shifting that code. It was an agonizing name decision because there were Java services, but we didn't want to call ourselves Java services in a Scala shop. Prohibitive. Anyway, just recently I read the name Vintage for sort of vintage services because people didn't like the moniker of legacy. I'm not so sure whether I want to buy legacy clothes and develop vintage services. Anyway, so legacy systems, they're in government departments, they're in banking backends, they're insurance. In most big organizations you go to, you will probably find some old big mainframe sat at the back somewhere. But actually, that's the thing that makes the money. That's the thing that runs for 12 years and has been making money for 12 years or 20 years or 25 years. You know, you have to sort of ask yourself, does that mean that legacy code is rubbish because it's been running so long and it's been doing its job? It actually does create a lot of value. So I think legacy is a bad name because it doesn't mean that legacy needs to hang around forever. Of course, it doesn't mean that, but it means that legacy, it's not something that is a bad thing and you should fear and that you should get rid of at the earliest opportunity. Sometimes the systems that you've got are just that. Anyway, so we were moving things out of the cloud, and we had a system where we sort of lifted it and shifted it, but we didn't do a big bang release. We sort of put in controls where we took traffic from the old to the new, and we had a slider that we can migrate that easily. And that's, I think, one of the things that's how to deal with legacy systems. You don't want to sort of go away and create something completely new and then replace it. You do apply the lessons of continuous delivery to it. We lifted it, we shifted it, we switched the traffic over in small slices. Because we didn't have the tests, we had to rely on basically testing in production, because the tests told us relatively little. We didn't have the domain knowledge to basically recreate all the tests, because that would have taken an age. We might as well have rewritten it. So we tested in production. Right, on to my next section, the maintenance death spiral. Let's see how much worse it can get. So what's the problem with legacy code is, well, first of all, you can't get anyone to look after it, because who wants to look after this old bloody legacy stuff? I don't want to touch it. This is just outdated. And these are sort of, they're made up quotes, but you can read them and you can think, yeah, this is not the sexy work that I signed up to become a continuous deliverer for. And it's a bit of a chicken and egg situation, because this is what I call the maintenance death spiral. So it doesn't really matter where you start. If you start by that nobody wants to touch it, which means that there's no improvements, which means that there'll be a high churn of people, because nobody is improving the code. If the code is really awful to work with, people don't want to stick around and create a lot of system knowledge, which then leads us to not wanting to touch the code, because, oh, well, we don't want to touch it because we might break it. It gets even worse if you have legacy system and you've outsourced their maintenance, because then not only do you lose all the internal knowledge, you hand it off to somebody else. I think the people who make the changes should be the ones that know the system, and vice versa. The people that know the system should be the ones that make the changes. Now, Phil mentioned you build it, you run it before in the talk before, and I think that is the way out of the maintenance death spiral. Nobody creates legacy code intentionally. There's no supplier in the world who will go, right, I'm just going to hack this in and create it. But this is kind of what you often end up with, a situation where, because the knowledge about a system has left the building, you end up with something that ends up being really quite brittle. And there's other sort of reasons why this might happen. You might be in an organization where you tender for support contracts, and the people who win it are usually the ones that bid the lowest. Or you might say, we need to save costs, and we'll have a pay cut for the experienced engineers, who then go, okay, I'll go somewhere else. And it takes months to get up to speed. So it's always a problem, but that's how you can very easily create legacy code. Now, this is, when we were working on this legacy code, this is how we sort of tried to get ourselves out of it. Now, this was from a time before COVID, obviously. We still had a whiteboard. We were able to touch it, feel it. But what we did was split up the work. We categorized all the things that we had to do into live issue, planned work, and operability improvements. And they are quite different. But you can't do one without the other. You can't leave a system to fester, to not fix the bugs. For once, the customer will stop paying your contract. If you're not making improvements, they're kind of, again, they'll give it to somebody else who'll tell them, yeah, we give you lots more features. Now, it is all about balance. Sometimes you will focus on live issues. Sometimes you will focus on operability. Next, I'm going to talk about metaphors. I really like when people talk about language because there's so much in language. It's funny, if you just think about, if you called a new project centralized authorization, what will the teams think? Oh, taking away control. It might not be your intent to take away control. Anyway, language is really important. And Emily had a fascinating talk about trying to simplify language. We don't want to have all the business speak and use ChatGPT to turn one line of email into a massive 50 paragraphs. So I think this is what we usually use. We use the greenfield and brownfield construction analogy for software development. People tend to be excited about using the shiny new frameworks, building it right from start, not making the mistakes of the people in the past. And brownfield is just something that, you know, who wants to build on an abandoned coal mine? It just feels dirty. So obviously everyone will want to work on those. So if you go in and say to a team, right, we're going to do some greenfield development, yes, we can recruit for that. You're never going to go in and say, right, you're going to go into brownfield development, yes. No, it's not. So that's not the only problem. Builders and maintainers are usually different jobs. You know, you get the big outside consultancy as the construction conglomerate that puts up all the new houses. And then you get Dave, who's got the roofing company, who also does bathrooms, who's your offshoring service company that looks after the code after you've put it in. That's where I don't think the construction metaphor for software development really works, because you don't want to be in that situation, because that leads automatically to legacy systems that are not supported. So that's the wrong job. I quite liked Andy Hunt and Dave Thomas, who sort of said, who looked at it more like garden maintenance. You know, you have a constant assumption of maintenance. You always need to do something. You don't just, you know, finish the garden and then it takes care of itself. It's the same in software. You don't finish it and then says, right, I don't need to look after it. I hand it to a live services team who can have 50 services and look after it. It doesn't really work like that. I think there's another way of thinking about this, specifically to legacy code. It's sort of cathedral renovation. Because essentially you've got some old building, okay, it needs to have lots of maintenance. Very often the plans of how it was built are lost in the mist of time. If you have the pleasure of using Confluence for documentation, you will know that whatever documentation you put in, you will never find again. Sometimes the skills for maintaining it are no longer available. You know, who nowadays knows about how to assemble a war file? It basically means that we often need the equivalent of archaeology in order to find out how a system really works. And the other thing is, you know, they did kind of know what they were doing back then. I think one of the biggest fallacies is to say, you know, oh, the system is old, therefore it must be rubbish. Terrible old system. There's no steel, no glass in the Sistine Chapel. Absolutely awful. Absolutely. Right. The next thing that I want to talk about when it comes to legacy is to talk about that experience matters. If you want to unpick complex code, add test, add observability, do that. I know you wouldn't do it. Do that cathedral renovation. You need experienced people to do it. You need the kind of people who understand the domain, who understand the system. Now, yesterday in Marcel's talk, he talked about that there were 200 regulatory changes a year. There's always change. there's legal changes, there's changing requirements. So you're going to need some people who make changes. And if you've got a big, massive spaghetti bundle of legacy code, you're still going to need people to make change. But actually to unpick that does take a lot of experience. You're not going to be able to put a graduate in front of a bit of legacy code and says, yeah, right, just fix it. It only needs this new button. You know, I was in a situation where we had to add a new field to a bit of legacy code, and it took the engineer the best part of a month because it was all about unpicking the changes. So it actually really needs some good people in order to look after a system. And that's just keeping it running. And it kind of goes against the sort of ideas of, oh, well, I've just got an old system. It's in maintenance mode. I just need a few things. It's the wrong language. Yeah, the Louvre Palace, for example, it wasn't built with the glass pyramid or the Mona Lisa inside. So, you know, needs experienced people. How do you get that? I think I'm actually quite surprised. This is an Agile conference, and I've not heard the term two-pizza team. I thought I was going to make a reference to this, definitely. Yeah, I think the important bit when dealing with legacy is that you need to have the same sort of approaches. You can't just give it to, you know, we'll give it to one big team that looks after everything. You need a small team, and importantly, you need autonomy. In this context, it's also quite important to sort of say that, you know, humans are not resources. They're not, engineers aren't bums on seats that you can just replace. You know, I'm not just talking about legacy maintenance here, that's for software development in general. Yeah, it's very tricky, I think, to have the accountants department run the development teams and going, oh, we found a new supplier, it's 10% cheaper. What it needs for a team is to have a high level of autonomy and alignment. Autonomy means that they can make decisions on their own, but alignment means that they're all pulling in the same direction. You know, you don't want a place where you've got a big system and you might have a few different teams looking after it, and they're all sort of go in different directions in how they're going to support it. It's a difficult balance, but it can be done. Now, this is just some of the stuff that we used to do in the office. You can see the whiteboard again. We had the Batman symbol there is, we had a role called the Batman, and they were basically looking at all the logs, categorizing, you know, is something going wrong? It wasn't that they were looking at it all the time, but we had somebody there to sort of take charge of triaging problems as they come in. And obviously that's not something that only one person gets to do. You share the pain. The dartboard, by the way, is how we chose who does stand-up. Whoever got furthest away from the middle had to do stand-up. We got quite good at darts, it has to be said. Right, so what makes a great team? Agile. And by Agile, I mean the lowercase version of Agile. I don't mean prescriptive Agile frameworks where, you know, you use Jira and have stand-ups, then say, you know, yesterday I did this, today I'm doing this, I'm not blocked by anything. That's not Agile. Go and read the Agile Manifesto. I came to that actually relatively late. But the one thing that always stuck in my mind with the Agile Manifesto is we value people, not process. The implications of that are enormous. You know, you basically want to do what works for the team, and that's where the autonomy comes in really handy. And I think it's really important when you deal with a complex problem like legacy code. You want to remove the obstacles. You don't want to be in a situation where, you know, I need to deploy some change. Oh, great, fill in this form in triplicates, then go to the cab next Wednesday, and if they are all right with it, then you can maybe deploy. Ask for help. Don't be afraid to ask for help. Right, how are we doing for time? Right, so how about oh, wait, I'll slow down then. How about we just rewrite our legacy code? You know, it's the old framework, nobody knows this anymore. Let's just bin it and start again. Surely that's a good idea. You know, we can do it properly. We can use the right tech stack. We could just spin up a new team to build it. And we can make a big bang replacement, and we don't need to have the pain of migration. Don't. Just don't. Unless you do it right. Which means slicing and dicing it. If I just go back, the new team to build it is the wrong idea, because the people who have the knowledge about how a system works is the existing team. If you give all the building of the thing to a new team, then they're going to make all the mistakes of the existing software without even knowing about it. If you do a big bang replacement, you're going to spend 3 years building this new software, and then you've got a situation like the TSB bank, where they put the whole thing in and then nobody was able to use banking for 5 days. Big bang replacements are very, very dangerous. Doing it properly, that implies that the people before weren't trying to do it properly. The new shiny tech stack isn't always the solution. So yeah, don't do it. I'm not saying that you can't replace legacy systems, but the only way to replace them is to do it in an agile way, do it iteratively. Take small chunks that you can replace. There's several patterns that you could use. You can use a strangler pattern. You can use all kinds of things to sort of get functionality out and put it into elsewhere and then move it across. But don't do it all in one go, because it's a very difficult thing to complete. Right, last bit. I'm going to turn the tables on legacy. Ask not what you can do for legacy, ask what legacy can do for you. Now, for me, it's actually been really, really fun. This project, this lifting and shifting project, when you think about it, you know, you read the prospectus. We are going to take some existing services out of the data center and put it into the cloud. I was a software developer by trade. I wouldn't have thought that this is something where I would be really, really happy for 4 years, but that's how it turned out. It taught me to debug. And by that, I don't mean run the debugger. It means strategies for how can you evaluate systems, very complex systems. It taught me how to add value to systems without having to completely rewrite them. What can you do? Where can you identify things where you can make changes? How can you improve operability? It taught me that not all the solutions are technical. You know, sometimes you don't need a service. You could just use a spreadsheet. And the value of sort of having things that are good enough. You know, we heard at this conference more than once that perfection is the enemy of good. And as it turned out, it gave me a different career, because I enjoyed solving complex puzzles so much. I started finding security issues all over the place, so much so that I do that now, well, professionally, yeah. Not sure why I put the Rockstar reference on there. I am. Right. Coming towards the end now. One of the really important things when dealing with legacy code is to measure and celebrate success. It's so easy to have something where you're looking after an old system, you're making small improvements, and nobody shouts about it. You know, remember, this is the system that is making the payments, that is creating the value, that is generating the revenue, you keeping that running smoothly and without anybody shouting about it, because it hasn't fallen down, is actually a massive piece of success. So if you make small operability improvements, if you improve the way that the legacy system builds, that's a massive bit of success. And well, if you have a Slack channel and create one for small victories, that's a really good way of sharing. But the important point is that you do share. You know, if you work in a team that looks after some old code, it's just as valuable to shout about how the improvements that you're making than if you've done a bit of, you know, you created the latest Lambda function in AWS that's meant that you can run stuff without servers. Right. In this talk, I've talked about what legacy code is, what the maintenance death spiral is. I've talked about the importance of language, why experience matters, and a little bit of how you can get out of legacy. I hope I haven't gone over. I don't think I have. I hope it's given you food for thought. Maybe it makes you think. And actually, personally, I still would like to learn COBOL. Don't laugh. If you're looking for job security as a programmer, COBOL is probably the best bet to make, because the people who are currently looking after those systems are what, 70? They're either going to retire or going to die soon, and the systems aren't going away. So, questions?
Excellent. So questions, please. Over there. So is this working? Yeah. So you talked a bit about wrapping tests around legacy code. So if you have a legacy code base without any testing at all, where would you start in terms of how do you work out which bit to test? Is the best place to start, the most valuable place to start? And then how would you go about wrapping that in tests?
I'm going to use the most common cop-out and say it depends.
Yeah.
I mean, I would probably sort of try to work from two different directions. I try to work inside out to sort of say, okay, well, what are the kind of things that I can unit test? What are the things that I can check of code without doing what Phil and Steve will tell us end-to-end, not doing end-to-end testing? So I'd sort of see whether you can start making improvements. Because the thing is, you can unit test COBOL code if you really want to. You know, if you have a really old piece of Java software, you can still spin up some unit tests for it. There's nothing stopping you. It is about trying to find the right tool for the right kind of test. You know, sometimes you can test services in isolation. You can use patterns where you know, in the pattern where we were moving the stuff from the data center, where it was running on WebLogic instances, and then it was running in the cloud. And locally, we were running it on Apache Tomcat. But for the tests, we were able to spin up a version of Tomcat, run some tests, and then tear it back down again. So there is no sort of definitive answer, but as long as you sort of start trying to say, okay, well, somebody will test these things. And if they're doing it manually, then you can sort of start thinking, well, how can I possibly do this automatically? And it's to a certain extent is no different from the advice that Phil gave us in the previous talk, where it was all about, you know, working in small steps, trying to move towards environments that are sort of dedicated for tests, putting in observability, putting in feature switches. Because, you know, if a code base is 20 years old, you can still put in the if statement that checks a feature flag somewhere. There's nothing stopping you in doing these things. And I think they're all things that you can do. But it does require people to go in, read the existing code, understand the existing code, and then kind of go, where can I make those changes? This was the green swim lane that you saw on the thing about making the operability changes. That's what this was about. You kind of go, well, how can we improve this particular process? This is a pain point. If you identify them, then you can start thinking about doing something about it. So I hope that sort of answers the questions. I probably think not, but it sounded good.
I mean, you're right.
Thank you.
Cool. Next question, back at the front. I understand that the end-to-end test is not a very great idea in terms of when you test the systems, but when we talk about legacy, doesn't it make sense to wrap the whole service in terms of end-to-end test so that it creates a shell around it and makes it easier to make changes?
The problem with legacy systems and end-to-end tests is that the problem that I think that you'll very often find with doing end-to-end tests with legacy systems that is actually really, really difficult to set up test data. If you've got, even if you have a QA environment, which sometimes, you find things where it's like, yeah, where do we test it? Well, we've got this environment over there, but it's being used by this other project because they need to test the changes, or the thing that is over in the environment is 5 releases from the next thing. Sometimes it's very difficult to actually find it. Sometimes even more difficult to have repeatable tests, because especially when you have tests that alter data, very often when it comes to legacy systems, it's not that easy to have things that restore the data from a sort of clean state. So for that kind of thing, it makes more sense to try and test the system in isolation and put stubs in to sort of simulate the behavior, because more often than not, again, following on from what Phil said, you have the situation where it doesn't really matter what you do, because as soon as it hits production, you find some new 15 edge cases that you hadn't considered. So I think the important thing is that the only difference between sort of software development with the new Shiny framework and legacy is that some of the techniques feel a bit dated, but some of the source code, the way you do things is a bit dated, but the principles of software development with legacy code are still the same. Still want to apply the same patterns, and the only way that you can deal with legacy code is to sort of try and say, okay, well, why can't we run automated tests against it? I heard a talk by forget her name, Rosalind from IBM. They are doing automated testing against IBM mainframes because the value of doing things in a sort of DevOpsy type of way has been shown. Hope that helps.
Oh, any other questions? Yep, on the back.
How do you break the perception within the wider business that you're a very valuable team and not just the bug fixers away in the corner?
You asked them how much money it generates. How much revenue would you do if we switched off this old legacy thing? And most of the time, well, we can't do that because bills no longer get processed. If you can put a monetary value on it and say, if this stops working, then the next thing happens. The thing sometimes I find, because I've now got a security hat, it sort of tend to ask, well, what would happen if this old piece of software that hasn't had its libraries updated in 10 years is using versions that are not supported and have got 1,200 security issues with it? How would it be if that suddenly stops working? And then I think it's all about trying to sort of say, well, this is the value that it brings. That makes sense.
Okay, thanks very much, Gerald.